So let us go with explaining. First of all, before dynamics, we have to see what is kinematics, is it not? Or velocity and acceleration, basically. So we are in dynamics. Okay, in mechanics, there are two sides. Dynamics. Okay, statics and dynamics. Okay, in dynamics, you can say kinetics and kinematics, like that we go. Okay, so now when we consider dynamics, okay, first of all, we will understand the general notions. First point is differentiation of a vector with respect to time. Let us understand first one, differentiation of a vector with respect to time. Let us understand this first. Okay, now first of all, in that, let us say if a function, if a scalar, if a scalar function, if a scalar function which is a function f is a function of time, okay, that is f is equal to f of t, then d f of t divided by dt is actually equal to limit delta t tending to 0. We have f of t plus delta t minus f of t divided by delta t, correct? Now what is it for a vector function is important. Similarly, for a vector function, for a vector function capital F, which is a function of time, which is a function of time, that is f is equal to f of t, okay, d of f of t by dt is equal to limit delta t tending to 0 f into t plus delta t. F will put it as a vector here, f of t plus delta t minus f of t divided by delta t. Now the question what comes here is, how do we take this f and f of t? That is important here. Okay, let us understand this much further in the next slide. This is the simple definition. Just like scalar, you can put it like this, f of t here. You can put it directly like this, d of f of t. Nothing great. Okay, but how does d of f of t comes into picture? That is important. Okay, let us see that. Next slide, we will see that. Okay, f can be any vector function. Let us take the first vector function which is there, which is distance or position. Change in the position with respect to time gives velocity, is it not? So let us first see change in the position first of all. Students, we are going much deeper than what was done last time. Okay, we are doing a lot of other concepts also. Okay, so people who have attended the previous classes do not think, sir, it is the same repetition, so we will not attend. No, attend. How many are there now? Numbers are reducing. 16. Okay, fine. Who's not there? Sharon is there. Sharon not there. Okay, fine. Divya Mani is not there. Okay. Megha is there. Okay, fine. Not much of this one, but still. Okay. Done? Done, students? Let us see. Now, the first one, differentiation of position vector. Okay, in that differentiation of position vector with respect to time. With respect to time, differentiation of position vector with respect to time. Let us see this. Okay, so if I have, say this is x, this is y, this is z, and let us say position goes from, say this is r of t, it moves from r of t, or we will say r1 point 1 to point 2, say r2. Okay, now the position has moved from, say, r1 to r2, correct? Or we can say like this, r1 to r2. This is the position. See, this is a vectorial differentiation. Observe. Sorry, vectorial difference. It's a vector product, right? So what is this? This one, s, or let us say delta s. Okay, this delta s is actually equal to r2 minus r1. This can be also said r of t plus delta t minus r of t. Makes sense? Makes sense, students? Because r2 is at another state. R1 is at the initial state. I can say that. So delta S is R. Everything is a vector. Keep in mind, everything is a vector. Okay. So we have delta S is a vector. Okay. So R t plus delta t minus R of t. It's a vectorial addition or vectorial subtraction. It is not simple one. Okay. So that's it. Now what is dr by dt if you have to consider? Okay, so if you want to find what is dr by dt, if you want to find out dr by dt, this becomes limit delta t tending to 0. We have r into t plus delta t minus r of t, r of t, this you can say r1 and r2, divided by delta t. Makes sense? This is dr by dt. Now what is dr by dt? This can be similar to s also. How? Let us take. Okay, if I consider what is delta r, okay, so if I consider delta r, if I let us understand this properly. Okay, so now let us have okay, say I am moving along this path. Okay, let me write it again here. Same thing, I'm writing it over here. There is a small understanding which has to come here, students. Very, very small understanding. Okay, so we have say point 1 and point 2. Now from point 1 to point 2, let us go along a line which is said by S. Say there is a S line. The particle trajectory is told by S. For example, we are taking particle trajectory along S. Now what is this? This one is R of say t. And what is this? This is R of t plus delta t. Makes sense? And this one can be written as delta S or delta R. Delta S, now observe here, just try to understand. Now when I consider a curve like this, when I consider a curve in this fashion, delta R, when you take, say this is R1, this is R2. Delta R is this distance. This is delta R. This is delta R. What is delta S? Delta S is along the curved length. What is it? Delta R. See, delta R is this one. Okay. This is delta R. Delta S is along this curved line. Now, delta S tends to delta R when this angle becomes very less. Okay, when the angle becomes very less, only then delta R tends to delta S. Delta R tends to delta S when theta is, or you can say, yeah, delta theta tends to 0, or delta t tends to 0. Makes sense? So delta R tends to delta S, delta R tends to delta S when delta theta tends to 0 or delta t tends to 0. Very, very important. Okay. Let us understand further. There is something more fundamental to be understood here. This is simple only, but I know I'm going to the depth of this. Okay.
ಸರ್ ಒಮ್ಮೆ ಲಾಸ್ಟ್ ಸ್ಲೈಡ್ ಒಮ್ಮೆ ತೋರಿಸ್ಬೋದು?
Vector function or scalar function ಅಷ್ಟೇ ಇರೋದು. Done.
Yes, sir.
Sir, then ds by dt is not exactly equal to dr by dt. No?
We will see that whether ds by dt is equal to, next point is that only. Okay.
I mean, delta s by delta t is not equal to delta r by delta t. No?
Yes. In case, no, delta r by delta t is equal to delta s by delta t. Why? Because delta t tends to 0, is it not? When delta
Yes,
t tends to
yes.
0, delta theta tends to 0, is it not? Understand that.
Like ds by dt may be equal to dr by dt, but delta s by delta t won't be equal to that because the distance is
Yes,
large. No?
yes, yes, yes. When delta s is delta t is not equal to, is not tending to 0, then what you are saying is right.
Yeah, yes.
That is the difference between speed and velocity. That's what I wanted to show. When you go along delta s, it is what you're calculating is speed.
Yes.
When you're considering delta r by delta t, you're considering the velocity. Makes sense?
Yes, sir.
Shall we go further? Everybody?
Yes, sir.
Fine. Now, one more point here. Now, if I say, what is delta r by delta s? Okay. Now, delta r by delta s may tend to, okay, delta s, when this tends to, okay, when, let it, when delta t tends to 0, delta theta tends to 0, and delta r by delta s, which was initially not tending to this one, tends to delta s into epsilon t. This epsilon t is the unit vector. Okay, let us put it as unit vector. Let us put how. Okay, yes, let us put epsilon t tangential unit vector. Okay, this unit vector along delta s. So this tends to unit vector along the tangential direction, which is unit vector that is perpendicular to r1 or tangent to s curve at point 1. Very important. At point 1. Now, if I consider like that, if I say dr by dt, velocity, if I consider velocity, okay, velocity, velocity v can be written as dr by dt. This can also be written as limit delta t tending to 0. We can write this as delta s by delta t into delta r by delta s. I can write it like this. Or this can be written as equal to ds by dt, ds by dt into epsilon t tangential. So velocity at that point goes in the tangential direction to r, to that curve. Observe. So what is happening? The velocity is change in s per time into tangential direction. So we can write this again as dr by dt is equal to ds by ds by dt. S I am not having vector. See here, observe here. This s, if I say vector, I am wrong. It is not a vector. Okay, it's an equation of the curve. Okay, so it's an equation of a curve, not a vector. R is a vector. S is not a vector. Okay, so ds by dt into epsilon t unit vector. Makes sense? Will be used a lot. Okay, will be used a lot. Similarly, let us write acceleration also. Similarly, acceleration, acceleration a is equal to dv by dt, which can be equal to d square r by dt square. Simple and straight, nothing great in that. Okay. What is dr by dt? We can write ds by dt. We'll not go further on to this. We'll stop here. Okay. So this is how we can find the acceleration vector. Simple and straight, nothing. Then we will see in terms of different components. We will
Sir,
take, yes, please.
sir, can you please explain this from this one? When delta t tends to 0 and theta. From there.
From here, right? At this point, is it not? From here, is it not? Or back side?
Yes, sir. Above.
Here, this one. This
Yes.
one.
Yeah.
See, when delta t tending to 0, theta tends to 0, correct? Because the particle over here is moving along s trajectory, correct? So when delta t tends to 0, r plus t, r of t plus delta t tends to r of t, correct? Getting it? Hello.
Yes, sir. Yes, sir.
So what is happening? This delta theta here. Observe here. If I say this is delta theta tends to 0. So what I am saying here, delta t tends to 0, delta theta tends to 0. And delta r by delta s tends to delta s into epsilon t along, that is the tangent to the, or perpendicular to r1, or tangent to the s curve at point 1. Makes sense? Makes sense.
Sir, why is that delta s into this thing divided by delta s?
Delta s from here only. What is
Okay.
delta r? Delta
Okay.
s along that unit vector.
Okay, sir. Yes.
So delta s cancels, you get epsilon t, which is a unit vector. Make sense?
Yes, sir. Yes.
Similar way, the other things also, correct? Is it clear?
Yes, sir. I understood.
Now you have to keep in mind, S is the path. Very important to understand that S is path. This is change in the position vector. Keep in mind, this is position vector. So we are relating position with path. Make sense? Write this down, students. Next we will go further. Okay. Step by step we will see. Done, students. Come on. Hello. Done writing? No.
Done, sir.
Very good. Others? Now let us go.
Done.
No, no, not done. Okay, please do it.
Done, sir.
Done. Okay. Now let us go with rectangular components. Now we will go with velocity acceleration with the different components. Okay. In rectangular components, velocity and acceleration in rectangular components is the next topic. Velocity and acceleration in rectangular components. Velocity and acceleration in rectangular components. Let us see that. Okay. First thing, if I consider r in rectangular components, the position vector in rectangular components, the position vector, rectangular coordinates, I'm sorry, in rectangular coordinates, I'm very sorry, coordinates or Cartesian coordinates. Okay. The position vector r can be written as equal to x of, I will say r of t, can be written as x of t I plus y of t j plus z of t k. Correct. Now if I consider velocity dr by dt, what this is velocity with respect to time. This one will be equal to d of x of t, dx of t by dt I plus dy of t dt j plus dz of t dt k. Makes sense? What is acceleration? Simple and straight. There is nothing great in that, which you knew already. It is d square r by dt square, which is equal to dv t by dt. Now this will be equal to d square x of t by dt square plus d square y of t by dt square plus d square z of t by dt square. K j I missed that. Correct? I j k. Makes sense? Simple and straight. Okay. Now it may so happen that if from acceleration, if you have to find out the velocities, we can always integrate. Okay. Differentiation to find out the acceleration, integration to find out the position vector from the acceleration part. We can do that always, is it not? Next, we will do a problem and let us see. One second, students, I just. Done, students?
No, sir, 1 minute.
Okay, don't worry. I'm not worried at all about the speed. Done, students? Don't worry, don't worry. Take time, but still. Shiveja is there?
Done, sir.
Very good. Shiveja is there? No? Where is Shiveja? Shiveja is there. Yes, yes. Because I want the new people to be there always. Okay, because this is very, very. If you miss this later on, it becomes difficult. Okay. Let us do an example. Okay, this has been done a number of times. Okay, for other students. Example. The example is like this. We have an elliptical trammel. Ellipse with the major axis. We have an elliptical trammel. Say it is like this. This is a slot. Okay, this is a slot. This is a slot which is ellipse, and this distance is 10 feet, and this distance is 6 feet. Okay, big one. Okay, and here on this one, say this is y and this is x. Okay, write it proper ellipse. This is x. Now here there is a pin. There is a pin here. Okay, and this pin is connected by a yoke. It is called a yoke. Yoke means it's a slot only here. There is another slot over here. Okay. Okay, there's a slot here. And let me write like this. Okay. This is the elliptical trammel which is there. And let me hash it. Okay, that's a trammel which is moving. Okay, now this yoke is moving in this direction with a speed of 6 feet per second. We are having the speed of 6 feet per second is the speed. This is the yoke. This is called the yoke, and yoke is moving with 6 feet per second. And this is the pin. These are the pin that slides. Pin that slides in the elliptical slot. Elliptical slot, as well as the slot in the yoke, as well as the slot in the yoke. Now the question is, there is a pin. This pin is pin A. This is the pin at A. This is the pin B. Now the question is, questions are like this. Okay, A. Question A. Question. I'll say 1. Question 1 is, I'll write it like this. So question 1. Question 1. Okay. What is the speed? What is the speed? What is the speed at which the pins approach each other? What is the speed with which the pins approach each other? What is the speed? If I'm sitting at A, how well the B is coming near me? That is what is the question. Okay. When the yoke slot, when the yoke slot is at x is equal to 5 feet, when x is equal to 5 feet, this is 5 feet, what is the speed with which it is coming? Okay, next question is this. Question 2. Question 2 is, what is the rate of change of speed? What is the rate of change of speed? What is the rate of change of speed towards each other? Speed of the pins towards each other, toward each other, toward each other, when the yoke slot, when the yoke slot is at x is equal to 5 feet. That is the question. Write the question first, students. Okay. Once the question is done, we will go back and see how to solve it. It's actually very easy. Ashutosh, Akshay, you should do it very fast. Okay. Ashutosh, Akshay, Grishma. Grishma, you remember this? And who else? Diviraj. I don't know whether Lakshmi Narayana has attended this class. Gyanendra. Gyanendra, you attended this class, right? Gyanendra.
No, sir, I was not there for this.
Okay, then fine. Grishma was there.
No, sir.
It's
Other,
becoming new, is it?
yeah, sir.
Okay, then it's fine. This classes you never attended, Grishma, till now?
No, sir.
Okay. Then Sharan also may not have attended. Anyhow, don't worry. So please attend again and again, only then the things will be clear. Okay. Ashutosh remembers this, is it not? Ashutosh ji.
I remember vaguely something by divided by 5, 6 divided by 10. We have to differentiate that, something like that.
Okay, right. Akshay, you remember, right?
Hello,
Akshay,
sir. Yes, sir.
you remember this, is it not? Okay. Tell me when you're finished writing this, okay? Now, what is the equation of an ellipse? The equation of ellipse is which says S. This is the path S, right? Like we have done in the previous case. This one is the path S. Here the path S is what? The path S is the ellipse, correct? Equation of the ellipse or equation of the path. Equation of the path is the equation of the ellipse, correct? What is that? What is the equation of the ellipse? X square by a square plus y square by b square is equal to 1, where a and b are major axis. This is a major semi-major axis. This is semi-major axis and this is semi-minor axis, correct? This is the equation of the ellipse, correct? So it goes along this ellipse. That is the main thing. That's it. So when it is going along the ellipse, how to do it? Let us see. Tell me when you're finished writing, students, okay?
ಸರ್ ಒಮ್ಮೆ ಅದು ಎರಡು ಸ್ಲೈಡ್ ಒಮ್ಮೆ ಹಿಂದೆ ಹೋಗ್ತೀವಿ ಒಮ್ಮೆ ಒಂದು ಡೌಟ್
ಇದಾ
ಅದು ಎಪ್ಸಿಲಾನ್ ಟಿ ಇದು ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲ
ಎಕ್ಸಾಕ್ಟ್ಲಿ.
ಒಮ್ಮೆ ಹಿಂದೆ ಒಂದು ಸ್ಲೈಡ್ ಹಿಂದೆ ಹೋಗ್ತೀರಾ ಡೆಲ್ಟಾ ಆರ್ ಬೈ ಡೆಲ್ಟಾ ಎಸ್ ಅಲ್ಲ ಓಕೆ
ಬೇಸಿಕ್ಸ್ ಕ್ಲಿಯರ್ ಆಗಬೇಕು.
ಹೌದಾ
ಇದು ಬೇಸಿಕ್ಸ್ ಸರ್ ಯಾಕೆ ಬೇಕು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಇದೇ ನಮ್ಗೆ ಟಫ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಆಗುವಂಥದ್ದು.
ಹೌದು ಸರ್ ಡೆಲ್ಟಾ ಎಸ್ ಬೈ ಡೆಲ್ಟಾ ಆರ್ ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡ್ ಡೆಲ್ಟಾ ಎಸ್ ಬೈ ಡೆಲ್ಟಾ ಆರ್ ಇಸ್ ಅಲ್ಲ ಸಾರಿ ಡೆಲ್ಟಾ ಆರ್ ಬೈ ಡೆಲ್ಟಾ ಎಸ್ ಇಸ್ ಎಪ್ಸಿಲಾನ್ ಟಿ.
ಎಕ್ಸಾಕ್ಟ್ಲಿ. when delta t tends to 0 only then ಕಂಡೀಷನ್ ಉಂಟಲ್ಲಿ. ಕಂಡೀಷನ್ ಏನು? ಡೆಲ್ಟಾ ಟಿ ಟೆಂಡ್ಸ್ ಟು 0 ಓನ್ಲಿ ದೆನ್. ಅದನ್ನು ರೂಲ್ ಆಗಿ ತಗೋಬೇಡಿ. ಡು ನಾಟ್ ಟೇಕ್ ಇಟ್ ಆಸ್ ಅ ರೂಲ್. ವೆನ್ ಡೆಲ್ಟಾ ಟಿ ಟೆಂಡ್ಸ್ ಟು 0 ಓನ್ಲಿ ದೆನ್ this has to be there, only then this is true, otherwise no.
Okay.
See here, one more point here we have to mention. See this delta r is a vector. I'm sorry, I made mistake here. Put a delta r vector. That vector, this is a scalar. You see, delta s is a scalar. This is a scalar. And this is a vector.
So we can write delta r as delta s into epsilon t.
Epsilon t, correct.
Okay. ಅಷ್ಟೇ.
ಸಿಂಪಲ್ ಇದೆ, ಆದ್ರೆ ಸಟಲ್. ಸಿಂಪಲ್ ಬಟ್ ಸಟಲ್. ಸೂಕ್ಷ್ಮತೆ ಇದೆ ಇದರಲ್ಲಿ. ಸೂಕ್ಷ್ಮವನ್ನು ಅರ್ಥ ಮಾಡ್ಬೇಕಷ್ಟೇ. Just equations ಬರ್ದೆ ಸಾಕಾಗಲ್ಲ.
ಹೌದು.
Done? Yes. Now how to solve this? Now the S is satisfied. The S
1 minute,
curve.
so 1 minute. 1 minute to the previous like 1 minute.
Yes, please. Yes, please. Write it neatly, okay? Because later on you have to refer this again and again. So if you don't write it neatly, then you will suffer. Time is there, ample amount of time is there, don't have to worry. And even if there is no time, you should not hurry. Because whatever is there, only that we have, whatever we have completed, we have to complete it properly. Okay? So there is no point in hurrying.
Done, sir.
Very good. Now let us go for the, okay. Now, very, very important thing to see here is the S, what is there? The path, which we are taking, the path S is the path of the ellipse. Here it is nothing but x square by 10 square, correct? Plus y square by 6 square is equal to 1. Makes sense? Clear? Now, how to differentiate this? So to find out the velocity, we have to differentiate, right? To find velocity, differentiate 1. So when you differentiate 1, you get 2x into x dot divided by 10 square, 2x into x dot divided by, correct, no? 2x into x dot divided by 10 square plus 2y into y square divided by 6 square is equal to 0, correct? Or I can write x dot by 10 square plus y dot, sorry, not this y, this is not y square, y dot, I'm sorry, y dot, where x dot, here you have to keep in mind, here x dot is equal to dx by dt, which is not a vector. Y dot is dy by dt, which is also not a vector. Observe that the scalar components. Velocity is nothing but x dot I plus y dot j plus z dot k. Z is not there here, this much is enough. Make sense? So these are scalars, very important to know. These are scalar components. Scalar components of velocity. Simple things, but important ones. Divided by 6 square is equal to 0. Now what should happen here? What should happen here? Now what is x dot for that particular ellipse? X dot, we know it's given there. X dot is equal to 6 feet per second. Is it not? 6 feet per second, correct? 6 feet per second, correct? And what is x? X is given as 5 feet. What is y? Can we calculate y for the pins? We can do that, is it not? From the y can be calculated through equation of ellipse. Okay, what is y dot? That has to be seen. This y dot, say, so this y dot can be calculated. Y dot can be calculated for pin A and pin B, because we are worried about particle, right? So let us understand what is the velocity. Let us calculate what is the velocity of pin A, what is the velocity of pin B. That is the vertical velocity. Horizontal velocity, we know it's 6 feet per second. What is the vertical velocity? Whether it's up or down, vertical velocity is given by y dot, is it not? Vertical component of the velocity. Now using this, let us calculate the vertical component of the velocity. Let us do that. Do that, students. Find it out.
So can you explain that why x dot is 6 feet per second?
Because it is given in the equation. When this is
Oh,
going 6 feet per second, this also has to go to 6 feet per second, is it not? Because it is being pulled by the elliptical, this yoke. Yoke is pulling it, is it not?
I see.
Yes. That's why it is 6 feet. X is equal to 5 feet because it is given in the question when x is equal to 5 feet. Correct. Please do it.
Sir,
Yes, tell me, madam.
dy by dt is minus 2.086 feet per second.
Very good. That's correct. For which one? A or B?
B, sir.
B. Then what is A?
Plus 2.08 feet per
Correct.
second.
So what is the relative velocity?
We have to add that. No, we have to subtract that.
Yes. So velocity of A minus velocity of B. Velocity of B is negative. So velocity of A is 2.08 minus velocity of B is minus 2.08. So you add it up, you get 4.16 is the relative velocity. Correct.
Yes.
Approaching each other. Correct. Simple and straight. Good. When we do more and more, now concept we have to clear. Okay. And remember this. This comes as a, what you say, this comes as models to solve difficult question. So whenever difficult question comes, you have to remember whatever we have done in whatever the questions we have done in our book, we have done in our course, and then see whether that particular concept can be applied in solving a problem. Okay. Similar way to find out the acceleration, you differentiate again. That's it. Second time differentiation, you get the answer. See, Saint Joseph has put Pooja's 5th rank in B in civil engineering. But one of the problem is that Pooja did not make use of that 5th rank. No, she is intelligent, she'll grow, but still, the growth will, from starting from here, instead of starting from here, she has started from here. So she has to put more efforts. She is pursuing masters in computer aided design of structures in Malad College, Hassan. She could have done the same in IIT. Had she been persistent, very important. Had she been persistent.
ಯಾರು ಪೂಜೆ ಅವಳು 2020 ಬ್ಯಾಚ್ ಅವಳ?
ಹೌದು ಅವಳೆ.
ಓಕೆ.
ಎಂಟೆ ಬಿ ಆದ ಕೂಡಲೇ ಏನಾದ್ರೂ ಒಂದು ವರ್ಷ ವೇಸ್ಟ್ ಆಗ್ತದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಹೆದರಿಕೆ.
ಹೌದಾ?
ರ್ಯಾಂಕ್ ಸ್ಟೂಡೆಂಟ್ಗೆ ಹೆದರಿಕೆ ನೋಡಿ. ಓನ್ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ ಯಾವ್ದನ್ನ.
ಇದೆಲ್ಲ ರೆಕಾರ್ಡ್ ಆಗ್ತಾ ಉಂಟಲ್ಲ.
ಓಕೆ, ಐ ಆಮ್ ಸಾರಿ. ಹೌದೌದು, ಐ ಹ್ಯಾವ್ ಟು ಬಿ ಕೇರ್ಫುಲ್. ಓಕೆ, ಸಮಟೈಮ್ಸ್ ಐ rush into the things. Anyhow, it's okay, it's in public domain only. Correct. Somehow kindly do not show this to Pooja, that's it. I know, even if you show, what is the problem? It's a reality, is it not? I have a number of people like that who have missed their opportunity. Persistence is important, very important. Ranganath is there? Ranganath is there? Ranganath ilva? He might have some job. Ranganath is there? Y value. What is Y value?
Sir, I had a doubt.
Yes.
Sir, could you go to previous slide?
Yes, please.
Sir, when the yoke moves in the x direction in like at the speed of 6 feet per second, the pins move along the curve motion. Then,
Yes,
sir,
fine.
how the x velocity is 6 feet per second? Like,
Because when it moves, it takes it along, is it not? You cannot resist that. Yoke you cannot resist. So what will happen? This will have 6 feet per second. Not do anything. There will be a Y component. That's a different case because it moves along the slot. Correct. It has a Y component because it moves along the slot. It is pulled along this x-axis at the same speed as 6 feet per second. Correct.
okay, okay.
Makes sense.
Yeah.
How many of you did not understand what I'm saying now? How many of you did not understand? Prathamesh, others. Shane, others. What didn't you understand, Prathamesh?
Sir, that's how, sir. The component you said, no, one along X that is acting and along Y. Means slot is for
So
that
what is that?
elliptical only, no, sir.
Yes. See here, this is very important theory of machines as well as in vibrations. Okay, that's why I'm taking this directly. Okay. So here this yoke, which I'm putting in bold now, this yoke is moving to the right side. So when it is moving to the right side on this direction, this pin also has to move like this, is it not? It is like some strong
Yes, sir.
person pulling. Two small kids. Okay, say there is a small kid being pulled forward by their father. Okay, so they're pulling it. Okay, so it's going front. Is it not? They have to go by the velocity. Correct. Pin is small. Makes sense? And maybe mother is pulling towards like this. So what is happening? It will go here also because this slot makes it to move in that line. Makes sense? Hello.
Yes, sir.
Correct. Shane, your question is answered.
Yes, sir.
Correct. Good. Now tell me what is the answer. What is y? What is y? You have to find y through equation of ellipse. How? You say x square is 5 square divided by 10 square plus y square by 6 square is equal to 1. Find out the value of y. Make sense? Y comes as 5.2 feet. Applied. Grishma, did you get the acceleration?
Minus 3.32 feet per second.
Very
sir.
good. Very good. Very good. Very good. Very good. Good. Now what you have to do, you have to go back and refer whatever the things you have till today. Okay. The questions or imagine things. Okay. Yes. Read, imagine. See whether some more questions can be put on this one. open up your mind, thinking. Okay. Yes. And students, let me give you another challenge. Okay. So if you can frame some questions which others cannot solve, I'll be happy. Based on same concepts, frame some questions and give it to me. Challenge me, saying that, sir, you cannot solve this question. I framed this. That's how learning has to happen. Correct? Yes, students, done. How many of you have not got the answer for y dot, the velocity? Raise your hands. How many of you have not got
What is
the?
the answer?
You got the answer?
What is the value, sir?
5 point. The answer is 2.08. YB, the answer YB is equal to minus 2.08 feet per second, and YA is equal to 2.08 feet per second. Correct? Hello.
Sir, what is the YA and YB, sir?
Hmm? Sorry, not YA.
I
Y
don't
dot
understand,
A.
sir. What
Y
is
dot A. Y dot B. I'm sorry. Y dot A
sorry?
and Y dot B. This is Y dot B. YB. This is Y dot B. Y dot A. Make sense?
No, sir, I didn't understand. What more you have to calculate? Oh, for pin A and pin B.
See, what is the question? What is the speed at which the pins approach each other when the yoke slot is at x is equal to 5 feet?
5 feet.
Correct. That is the first question, right?
Yes, sir, yes, sir.
So that is
So
the
what
question.
speed of the calculate?
Correct. So this has come as minus 2.08. That means it is coming down. This comes as plus 2.08, comes up. So what is the speed at which it approaches? You have to add those two up, is it not? Correct. Have you got till here, Shane, first of all?
No, sir, no, sir, I didn't
Please
reach
do
there.
it fast.
No, sir, I went wrong somewhere.
Hmm?
Here now we have x dot x and y will take from the equation of the ellipse, right?
Correct.
That we are substituting in this x into x dot by 10 square.
Exactly, exactly. This 5.52 feet, 5.2 feet will go here in this y.
As
X
y.
dot will be 6 feet per second. X is equal to 5 feet.
5. Okay, okay.
Y dot you have to find out.
Then after finding y dot, you have to find out y of a and y dot of b.
See, this was for what? If it is x is equal to 5 feet, y, first of all, you have to calculate for slot A, slot B separately, is it not? Sorry, pin A. So you will get YB and YA separately. So Y dot A is separate, Y dot B is separate, is it not?
Oh, okay, okay. I've gone wrong there only. I've calculated only once y.
Do it fast. Others, how many of you have got the answer YA and YB? How many of you have got the answer for YA and YB? Grishma, you have got, I know. Others?
Yes, sir.
Akshay, then. Others?
I've
Ashutosh,
got
got
it.
it?
I've got it.
Divyaraj?
Sir, I did not get. Sir.
Okay, okay. Sagar did not get, is it not? Or did get?
Got it, sir.
Got it. Okay, the question was, did you get it? Okay. Yes. So Aditya, Shiveja, Nitin did not get the answer. Nitin did not get the answer. Nitin, are you there? Hello, Nitin. No. Got. Okay, very good. Did you get the acceleration, Nitin? Okay, very good.
Sir, I didn't understand. Sir. Like, can you solve and show?
See
The
what
y
happened.
part. Y part.
Huh? Which one?
Y. Like, after that,
See
from the
here,
equation,
first of all,
getting.
let us take for pin B. For pin B, what is y? For pin B, x is equal to 5, x dot is equal to 6 feet per second, y is equal to 5.2 feet, and y dot is not known. Let us find it out. So it is 5 square, right? So here we have x dot, correct, divided by 10 square plus y dot divided by 5 square is equal to 0. Let us put it, x is 5, x dot is 6 divided by 10 square plus y is 5.2, y dot we do not know, 5 square, that you get 0. So you get, this is yb. So yb, you get it as minus 2.08 feet per second, correct? For pin A, x is equal to 5, x dot is equal to 6 feet per second. Only difference is y is equal to minus 5.2 feet. And y dot we do not know. So what happens? You substitute that, you will get ya as plus 2.08 feet per second. Correct? Hello?
Yes, sir.
Simple. Shane, was it simple?
No, sir. Like I didn't understand. Like in a with respect to diagram, can I explain
This you understood how this came.
how we got why I understood? Yeah.
You understood first of all why did we come here like this, is it not?
Yes, sir. We have to
Till this
find
step
out.
you understood.
Till there I understood, sir. Yes, sir.
Okay. Now what you did not understand, what is YB and YA? That's it, is it not?
Yes, sir. And why we are taking minus 5.2 and plus 5.2?
Because if you consider the ellipse, equation of the ellipse, this is the equation of the ellipse, right? So now when you take the equation of the ellipse, what is equation of the ellipse? X square by 10 square plus y square by 5 square is equal to 1. Let us solve this. Put x is equal to 5 feet. Okay, x is equal to 5. Okay, 5 square by 10 square plus y square by 5 square is equal to 1. What are the two things we get? This is quadratic equation, is it not? So you will get y square is equal to 5 square into 1 minus 5 square by 10 square, correct? Make sense?
Yes, sir.
Okay, so what do you get here? What is 5 square by 10 square? 1 minus 25 by 100, correct? So it is y, calculate that, you will get plus or minus, is it not? You solve this, you get y is equal to plus or minus 5.2, correct? Plus is with respect to B, minus is with respect to A, correct?
Okay, okay, okay.
Correction. This is Y, this is X. So for every X, there are two Y's for an ellipse, is it not?
Yes, sir. Up and down movement. Okay, okay, okay.
Correct, yes. It is not only positive, it is minus also. Clear? Now calculate for acceleration. Calculate for acceleration. I'll come in a minute, students. Okay, I'll come in a minute. Okay. Just a second. Hello students, found the acceleration next. Hello. Shane?
Sir, I'm still doing the pin.
Yeah, please. Others? Shiveja, got the answers? Shiveja,
Good.
got very good. Okay. Why did Krishna leave? Sagar? Sagarji,
Acceleration didn't get velocity.
do acceleration. Yes. Siddhi Vinayaka?
So doing it, sir.
Yes. Deepesh, how did you feel? The question is, did you understand?
Yeah, understood. I mean acceleration, sir.
Very good, very good. Gyanendra?
Yeah, doing so.
No, please. Next, we will go with ballistics. Ballistic problem.
So here you have written 5 square, it is 6 square, right? 5,
Where, Baba?
5.2
X.
into YB. That is a mistake, it's 6 square.
Sorry. Because 6 feet is given, is it not? Is it 6 feet? No,
Uh,
I'm right, Baba, because x is equal to 5 feet, no?
not x, not x, sir. That y by y dash divided by
Y by,
y dot divided by 5 square,
yes. Sorry, 6 square, correct. I'm sorry.
6 square. Yeah, yep.
I'm sorry. These small mistakes only changes everything. Tomorrow we will go with ballistics, or instead of going with ballistic, we will go with, yeah, we will see what to do. We will go with velocity in terms of, in cylindrical coordinates we will do first. Okay, then we will go with velocity as a path variables. Okay, so I think from tomorrow onwards, 2 days, I will go only with velocity and acceleration. Let me complete that for your vibrations. Okay. There is a JRF vacancy in NIT Surathkal, students. Okay. Lot of vacancies comes like that. Candidate should have qualified GATE at least once in his academic career. BE BTech in mechanical engineering and ME MTech in machine design. Candidates must have at least 60% CGPA in aggregate from a recognized technical institute or university as a full-time program. Candidate should have qualified GATE at least once in his career. Oh no, this is done. No, no, that's done. 13th September is the last date of application. So you see how important GATE is, students. Okay. Once you are qualified for GATE, it will help you every time in your career, wherever you go.
Sir, can you do the acceleration part, sir?
Very much, I can do it. I will do it. I was waiting for you to complete. Okay, because you have to do by yourself first. Only then things will be easier. Okay, if I do it here, you will get it easily. Fine. Okay, but then you will not be able to solve. Okay, you will not be able to do things by yourself. Very important. X dot divided by 10 square plus y into y dot divided by 6 square is equal to 0. Now when you differentiate this again, what it will come? You will get it as x double dot plus x dot square, correct, divided by 10 square plus y dot, we can have the same thing, y double dot plus y dot square is 6 square. You get this? Understood? How did we get this? This point is understood by everyone, or there are
Yes, sir.
somebody who's not? Huh?
The velocity you have to just add x dot and y dot.
No. We are this when you what is d of x into x dot? What is that? It is x into dx dot by dt. Okay, plus x dot dx by dt into x dot. Correct. Correct. No.
Yes, sir.
So what is that? This is x double dot plus x dot 2 times x dot square. Correct.
No, sir. I was asking about finding velocity. Previous step.
Okay. Here, what is the problem here? What's the trouble, dude?
No. Like to find velocity, we have to just add x dot and y dot. No, I was asking.
Yes. What you can do? Relative velocity. Relative velocity. You say VB with respect to A. If I say that is what VB or VA minus VB. Okay, that can be written as VA is how much is 2 meters per second 2.08 minus of minus 2.08, which is B. So what is it? 4.16, is it not?
Okay, sir.
Make sense?
Yes, sir.
Simple. Next, find out acceleration fast.
Sir, is x double dot given?
X double dot is given, yes. How? Because x is moving with a constant velocity. X is given as 6 feet per second. Okay, that
Okay.
means x double dot is equal to 0. Okay, that's how you can take it. So if x double dot goes to 0, this becomes x dot square by 10 square plus y into y double dot, which we do not know. Y dot we know, square 6 square. So it's easy to find out y double dot. Correct. Find it out.
So what's the answer for y double dot?
3.32 minus 3.32. 3.32 feet per second for B. What is it for A? Y double dot for A is 3.32 feet per second. You get the same. So Y in terms of acceleration of A with respect to B is equal to YB, sorry, B with respect to A. I'm sorry. B with respect to A is equal to YA minus YB. YA is 3.32 minus of minus 3.32. So the answer is 6.64 meters per second. Make sense? Similar way, if you want to consider A acceleration, A with respect to B, this is y double dot of B minus y double dot of A, which is equal to minus 3.32 minus of 3.32. So that is equal to minus 6.6 meters per second square. Make sense? Everyone has got the answer? Hello. Difficult question, but I hope you have understood how to do it. Is it not? Hello, students. Are you appreciating this problem?
Yes.
We are understanding one problem. All the concepts are solved. That's how the problems must be picked. That's why I go with the same problem each time. Done, students? Done, we will stop the class. Okay.